This is a tutorial on how to use the QDAP package to parse through and conduct some initial analysis on references and their abstracts for a meta-analysis. First thing we'll do is load the QDAP package. And then we have this URL underscore DL. That's just a convenience function in QDAP that allows me to share data sets with the user. When you run that, what that does is put into your working directory this ref test clean, and that's really a data set that's a continuation of the previous tutorial where we cleaned and read in to a data set. And we'll read that in with the read CSV and put it into a list so it looks like the previous tutorial. V was in a list format, V1 was the matches with abstracts. Okay, the next step in the analysis is crucial. This is where we supply word lists or dictionaries to termco_a. Now, termco_a is a function that can find terms in dialogue or text, but it's only as smart as the word list that's supplied to it. Let's have a look at this word list. You'll notice that it's a list made up of vectors. So let's actually look at what it looks like. We'll run it. You can see that it's a list and there's 4 vectors in there, named character vectors. And you'll want to make, if you're looking for gender for instance, you'll make a choices as a researcher about what terms to look for. So maybe we're looking for male, female, women, man, men, that type of thing, because we're trying to find studies with just women. So we'll pull those ones in and exclude the ones with men. Another important aspect of what termco_a actually does with that information is the spacing around your terms. You'll notice there's a space here, and here in man there's a space before man and after man. Let me explain to you how termco_a works. It looks for a space followed by male. So it would find male, males. The word read here has a space for it before it, so it would find read, reading, reads. If I were to delete that space, it would now find the word bread as well. Put the space back in, and you as a researcher may be thinking, this will also find the word ready. So what we can do is be more explicit. Put the word a space after it. Now it finds just the word read, but we need to still explicitly find the word reads, space after it, reading, and so on. So a researcher really has to think about the dictionaries that are being supplied to termco_a. Once the researcher has made that list of words to supply to termco_a to match up, the next is supply it to termco_a. And here we have wrapped termco_a function with, and then the data set we're working with. This is an easy way to supply a data set to a function in R. The first argument here to termco_a is your text variable, and in this case it's abstract. That's what we're searching through. Next is your grouping variable, and that's ID. Really, these are our journals. We want a separate output for each journal article. Next is the match list, and we're supplying to that matches. And you'll want to do short term equals true most likely, and also ignore case most likely. Ignore case will find here, it will find brain as we see it here, but it will also find it if the word were brain, it would also find that. Okay, let's run that and see what it looks like. Notice that for each grouping variable, which is the journal article, you'll notice that it outputs 2 values. The first one is the frequency, and then what's in parentheses is the percentage of that variable. So 3.28% of this journal article's abstract was dedicated to reading terms. 1.3% was dedicated to teaching terms. Let's have a look at what that output from termco A looks like. You'll notice it's actually a list with all of these different components. You're probably going to be, in a meta-analysis, most concerned with the raw one. These are the standard just frequencies. If you output that, you can see it's just the raw frequency counts. Now you as a researcher may say, well, I don't want the combined categories. I want to know for male, female, women, men. I want to see them all. The way we do that is to just unlist matches and supply that. See that it's unlisted and supply that to termco A. Keep everything else the same. Let's look at it. Wow, it's a lot bigger data frame. Extends a lot further. And let's look at the head of the raw. See a lot of zeros. Something to keep in mind here, V2 from up above, those were our missing abstract variables. We'd want to go and find any of the references that were missing abstracts. Okay, let's continue on. Next part of the analysis is start to exclude some of the some of the articles. The way we can do that is by looking at these columns. And let's say we wanted all articles that contain all of these. I don't know if we'll find any, but what we do is take A, raw, and it's a matrix, and we'll do row sums for that. And we'll look for any that are greater than 0. Or we could have done just for brain. Put that raw, that's number 1, 2, 3, 4, column 4, and know which ones are greater than 0 there. Same thing for reading or whatever column you want to. And Z, if you remember, was our data frame with our variables, and that included the abstracts and all the journal information. What we can do is just index that data frame with the logical vectors we just created. So for instance, brain, logical vector, there's a true. What we supply to that will output a data frame with just the journals that contain brain information. Could do, skipped a few lines here, all. That's any ones that contained any of the hits. We could combine those two booleans or whatever. Could also write that information out. We had that P. Could write that out to a table with the right table. Let's see, now we have that in a CSV file. This is a tutorial on how to use QDAP to parse through references and the abstracts to make decisions for meta-analysis.